Unified dynamics.
Take a particle with exactly zero angular momentum, no spin, no orbit, and drop it directly into the center of a black hole. Without a centrifugal barrier to slow the fall, general relativity predicts a total collapse. The particle plunges to the core and crushes into a singularity, a point of infinite density. Infinity is a mathematical error, not a physical property. This result is a system crash, signaling that the equations of relativity have reached their breaking point. The failure stems from our core model of the vacuum. We have treated spacetime as a smooth, continuous fabric, capable of being compressed forever. The unified dynamics framework replaces this smooth void with a discrete, pre-metric structure. It suggests space is a dynamically evolving network built from finite, individual units. To resolve the math and stabilize physics, we must accept that the universe has a hard resolution limit. At the Planck scale, the emptiness of space resolves into a complex, interlocking network. This network is composed of geometric pixels, formerly known as K4 tetrahedral nodes. At this layer, distance and time are not foundational. There is only combinatorial adjacency, a sequence of state updates moving across the edges of the tetrahedrons. Each node is governed by a strict vertex information capacity limit. This limit is locked at the mathematical ratio of 7/768. This ratio represents the absolute saturation point for local geometry. No single node can process more data than this fixed capacity allows. Because the fabric of space has a maximum pixel density, the physical world has a built-in floor that prevents it from ever reaching infinite density. When accumulating mass and energy push a region of space toward that 7/768 limit, the network has to compensate. To avoid a local structural collapse, the overloaded node must algorithmically shunt its excess processing debt to the nodes surrounding it. This outward push creates a localized structural tension called manifold torsion. This tension dilates the phase rigidity of the network, making it harder for information to flow through the congested area. Because congested space processes updates more slowly, moving objects naturally follow the path of least resistance. Billions of these microscopic corrections accumulate into a macroscopic trajectory bias. This collective bias generates the curved geometry and physical acceleration that general relativity identifies as gravity. Gravity is the statistical shadow of a discrete network, algorithmically routing data to maintain its own hardware integrity. At the scale of a black hole, these limits reach their ultimate expression. The unified dynamics framework defines the event horizon as a physical state of event horizon hardware. Inside this boundary, the density of matter has completely maxed out the 7/768 capacity of every node, creating a saturated boundary. Physical routing paths are completely choked at this depth. The local geometry is saturated, making it mathematically impossible for the black hole to accept any more density into its core. The collapsing matter hits a hard, discrete surface and stops. Without the ability to compress further, the predicted singularity never forms. This hardware limit resolves the black hole ingramation paradox. Quantum data is not destroyed. It hits the saturated core and is algorithmically bounced back toward the surface via triadic co-boundary leakage. By replacing the illusion of a smooth vacuum with the geometric granularity of space, the laws of physics remain stable. Reality protects its own data by enforcing a hard limit on infinity.